Okay, let's give you guys some more practice. So here, given the derivative equals this thing here, work out y of 10. So you can imagine this second derivative as being the acceleration here. So given the acceleration, um, then you have to somehow find y. Well, given the acceleration here, then what you do is you integrate it to get the velocity time, and then you integrate it again to get your displacement time, and your displacement in a way is like y. So the point here is that imagine this thing here as being your acceleration. So you've been given the acceleration time graph, and then in order to find out y at time equals 10 in a way, that's really you trying to get from here to here. But then what you do is you integrate it once, and then integrate it again to get you to the y. Okay, and these are the initial conditions here, because when you integrate this, you're going to get a whole family of possible answers, and then you would use this initial condition here to. But basically, when you integrate this, you're going to get something plus c. Use this condition here to work out this c, and then later on you've got to integrate this whole thing here. Then you're going to get something plus a different constant, and then to find out this constant here, then you would use this condition here to find out the c. Once you've got your c, then you would, well, press pause and have a go. Okay, so to do this here, so given this here, so in your mind visualize the three graphs. Okay, in your mind visualize the three graphs: acceleration time, velocity time, displacement time. You've been given this one here, so we've got to find the indefinite integral of this. That would then take us to velocity. In a way, this is like velocity. Okay, so picture the three graphs in your mind here. We need to find the indefinite integral. So we need to find the indefinite integral of this. So from here, integrate it. That will then give you this, because well, when you get to here, visualize this in your mind. 2 to the power of minus 3. That's what you've got at the moment here. That's what you've got at the moment. So to integrate, you need to find something that when you differentiate it, it will give you this, and it turns out to be this. Okay, so make your guess to be x to the power minus a half. When you differentiate x to the power minus a half, it will give you minus 2x to the power minus 3, and then make the adjustment here to give you a 2 here. Well, blah blah blah. If you find the indefinite integral of this, it will give you this. Okay, but then you still need to find your c. But basically, once you're here, tidy up, it will give you this. But you still need to find your c here. So use the initial condition, and the initial condition was given to us right from the start. It was given as this. And by the way, sometimes this thing here can be written as this. So y prime can sometimes be written as, well, y prime is like dy by dx, evaluated at t equals, so evaluated at whatever's here. So in this case, evaluated at x equals whatever this thing here is. So this here is just another notation. It's just another way of writing this thing here. So anyway, this thing here equals, that's this equal here, and then 1 equals 1 here. So sometimes this thing here can be written as this. Okay, it's just a notation. Anyway, we would use our initial condition here to work out c. So looking at this here, we would put the 1 here into here, and then put this into the whole thing here, because yeah. So that would then give us blah blah blah, c equals 2. So now we know dy by dx equals dy by dx equals this thing, and then the constant here is 2. Okay, so now we've got our velocity, if you like. So far we were given this, and then when you integrate it once, it will give you this thing here. We managed to work out our constant here, and if you get a graph plotter and plot this, it will give you something like this. Okay, so so if you think about it, when given this here, if you differentiate this, it will give you this thing here. Okay, well anyway, we now need to find out why. So now we need to integrate it another time here. We need to integrate it once more. Okay, so looking at this, integrate it. So to get y, we need to find the indefinite integral of this. So hang on. So to get y, we need to find the indefinite integral of this. Okay, and then well, when you're here, visualize this thing as visualize this thing here as minus. Currently, you've got minus x to the power minus 2. So what you need to think of something. So your first guess here should be x to the power of minus 1. But so this here should be your initial guess. If you differentiate this, it will give you minus 1 x to the power minus 1. We don't need this minus 1 here. And then sorry, to the power minus 2, sorry, here. So you see this thing here is exactly as what you've got here. So, well, blah, blah, blah. Find the indefinite integral of this, it will give you this thing here. Okay? And then use your initial condition to find out C here. So, so now we need to put this into here, and then into here, and then this thing here into here, just in order to work out C. Okay, so it's blah blah blah. C equals negative 2. So now we've got our y equals blah 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 here. So 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 initially we were given this. Integrate it, it will give you this. So this here you can imagine as being our acceleration, this is our velocity, and then this here is our displacement. You can imagine it like that. Okay, so this is our y here. So if you get a graph plotter and plot it, your graph will look like this. You see, this here is your acceleration. Okay, this here is your velocity, and this is your displacement. Okay. Well, the question was find find y of 10. So plug this into our equation here. Plug the 10 into here. Okay, and then it will give you this. So y of 10 here equals that. Okay, but if you get a graph plotter and plot it, it will look like this. Okay.